Well, guys, I don't know about you, Matrix. Completing the square is a little bit nasty, okay? It's really one of those things Matrix don't like. But now listen, there's another method of getting the x value of the turning point to get the axis of symmetry. Check this out. You probably remember this one, and this is so amazing. I don't know about you guys, but I'm seriously in love with this one. I'm seriously in love. Let's get a little red thing here. I am in love with method 2. Okay, it's this guy. Now watch this. This is a beautiful little formula. Let's put a heart around him. We're in love. Okay, minus b over 2a. You know why I'm in love? Because it stops you having to complete the square. Okay, but there's a little bit of a trick with this. Now, if you do this, I want to just rewrite the parabola. Okay, it's minus 1 x squared plus 2x plus 3. Remember that guy over there. What is this? This is so important. This guy is A, he is B, and he's C. A is minus 1, B is 2, and C is 3. So if we go into this formula, now watch this. The A is minus 1, the B is 2. Now if you substitute it in, minus B over 2A, well, the B is 2, the A is negative 1. And then if you look at this, the minuses cancel, and 2 over 2 is 1. Now that's 1, the same as you had in the previous example, well, it's the previous method. I mean, if you look at the previous one where you completed the square, look at this. This was going to be, what is that? That's negative x minus 1 squared plus 4. There is where your 1 is. That's it there. Do you see? But now the minus b over 2a is a far better method of doing it. Okay, so if you've got that, your x of your turning point is in fact 1 with minus b over 2a, much nicer. Now how do we get the corresponding y value, which we know from the previous method is 4? How do we do it? Very simply. Substitute the x value of the turning point into the original equation to get the y value of the turning point. Okay, now if you look at this, what we do is we go f of 1, remember x is 1, so the f of 1, substitute it in, and guess what? You get 4. So your turning point is then going to be x is 1, y is 4. Okay, the f of 1 is 4. And then we can immediately look at the y-intercept by letting x be 0. So if x is 0, y is 3. And then your x-intercepts, you let y be 0. Much easier. What we can do is bring everybody to the left, and then factorize as we normally did there. Okay, x minus 3, x equals minus 1. Okay, so x is 3 minus 1, and we can draw it. So what do we know? We've got our y-intercepts, our x-intercepts, and we also then can simply then get the graph. There's your axis of symmetry. X is equal to 1. That's your little turning point, your y-intercept, and your x-intercepts. And notice I've put the coordinates on there. Okay, so that's very, very important. Very, very important stuff. Okay, so just watch out for that. And then people, you'll notice the graph increases and decreases. Okay, and completing the square can be used, but I still prefer the minus b over 2a, especially if you've got x squared, something x, and a number. Okay, so be careful with that. Let's look at a little bit of determining the equation. What if they give you a picture? Okay, now in the first type, we've got our x-intercepts. Okay, now how do we do this? These are called the x-intercepts or the roots. Now hold on to that. If you're given a picture and they say find the equation, what are we given? The x-intercepts and a point on the parabola. Now this is quite nice because this is your first root and your second root, your first x-intercept and your y. And this is going to be a point on the line, not on the line, sorry, the parabola, which is x is 2 and y is minus 20. Okay, so let's see, what do we do with this? Okay, well, substitute in the x-intercepts. Be careful, it's y minus negative 3. You probably remember this. Then you've got x plus 3 and x minus 4. Now the trick is to get the value of a. We know it's negative, but we don't know whether it's minus 2, minus 3, or minus 4. So what do? We take that point 2 minus 20, where you've got an x and you've got a y. Okay, so look at this. Now remember, this is so important here. Okay, there's your x and there's your y. So the y goes there, and x goes into those places over here. Okay, and we plug it in, and there we go. Okay, so what does that give us? Well, if we add these, you get 5, and then subtract -2, so that gives you -20 is minus 10a, and then a is equal to 2. And then what does that tell you there? Okay, it gives you 2, which of course was the happy chappy. If it was negative, it was sad, and if it was positive, and remember our parabola that we given was happy. In previous examples, you get it to be sad. So now put the a back into this equation with the x's and y's. Okay, and you can times that out. X squared, 3 minus 4 is negative x, and then that gives it to you, and you have your equation if you times it out. Okay, now people, another type, okay, if you've got the axis of symmetry, if you've given it in completed square form, well, that's the axis of symmetry, and also your y value of the turning point is that. Now watch this quickly. There's a turning point, and this is a point on there. Your axis of symmetry is -1. Now people, watch this. Your axis of symmetry is -1. Now what I'm going to do is I do this, I bring it across and I plug it into the equation. Okay, it's much easier to do this. Your y value of your turning point is of course 8. Okay, and that's what you put in there. Now all you've got to now do is substitute back in with that point and do exactly the same as you did. I'm going to leave that as a challenge for you to do. And what I could do is, for this lesson, I'll put it on Facebook, the answer, the rest of the answer for this. So try it and then check it out tonight. And when we do this one, I'm going to actually do this one on Facebook and give you the answer as well. So try it and catch you later on Facebook. Guys, it's great being with you. Work hard on your parabolas, and let's see if you can get these marks in the matric final exam. Stay tuned. I'm Zanzi for sure, and see you around.